Hello everyone, welcome to Site Programming channel. I am Hemanth, belongs to Department of IT from Sesi Institute of Technology and Engineering. Now I am submitting the video assignment on how to solve a knapsack problem using backtracking process under the supervision of Nageshwara sir. Now before going to the actual problem, let us learn what is meant by knapsack. Knapsack refers to the commonplace problem of packing the most valuable or useful items without overloading the luggage. Suppose we are having a bag in which it can bear up to 15 kgs and we are having n number of objects with their respective weights. Now the knapsack will discuss about how we can fill this bag completely such that we can carry the most valuable items or useful items. Now let us learn what is a backtracking technique. Backtracking is a general algorithm for solving some computational problems, most notably constraint satisfaction problems. It incrementally builds candidates to the solutions and abandons a candidate's backtracks as soon as it determines that the candidate cannot be completed to a reasonable solution. So now let us discuss about how to solve an abstract problem using backtracking technique. Suppose if we are having 4 number of objects, each one is naming of x0, x1, x2 and x3 respectively. Each object is having a weight of 5, 8, 3 and 4. Let us consider these weights are in a form of kg forms and each object is bearing a profit of 10, 12, 6 and 8 respectively. Suppose if we are having the maximum capacity of 15 kgs, now let us solve this problem using the backtracking process. So for every backtracking process we need to generate a state space solution which is of a tree format. We all know that the tree is having a nodes where I am dividing that node into two parts, where the first part of the node will discuss about how much weight we are having and the second part of the node will discuss about how much profit we are gaining. Initially, I am making the root node as weight 0 and profit 0. So, for every node, there is of two parts. One is considered of this particular object and another one is not considering of that particular object. Suppose x not equals to 1, we'll discuss about we are considering that object. X not equal to 0, we'll discuss about we are not considering that particular object. Now, let us generate the state space solution. Let us start the process by considering the x0 object, that means first object. The first object x0 is having the weight of 5 kgs and profit of 10. That means we have to add this weight to the particular weight part and profit to the particular profit part. After adding, here it looks like. Before going into the further step, we have to compare the weight which we got here with the maximum capacity. The weight which we got is 5 kgs and the maximum capacity is 15 kgs. That means 5 is less than 15. That means we can move on to the further by considering the x1 object. The x1 object is having the weight of 8 kgs and profit of 12. That means we have to add this 8 to the particular weight part and 12 to the particular profit part. After adding, here it looks like. Again, we have to compare the weight which we got here with the maximum capacity. The 13 is less than the maximum capacity 15. That means we can move on to the further step by considering the next object, that is x2. The x2 is having the weight of 3 kgs and profit of 6. After adding this 3 to the particular weight part and 6 to its particular profit part, here it looks like. Here we can observe that the weight which we got exceeds the maximum capacity. That means the path which we chosen is a wrong path. Now we have to backtrack to the previous node, that means to its parent node. The parent node is still having another chance, that means not considering of that particular node as we discussed before. Here we considered x2. While considering the x2, the weight which we got exceeds its maximum capacity. That means we have to move on by not considering that particular node, that is x2. While not considering that particular node, we have to make sure that the weight and profit are same as its previous node. That means 12 and 22 as we can observe here. Now we can move on to the further step by considering the next object, that is x3 object. The x3 object is having the weight of 4 kgs with the profit of 8. That means we have to add this 4 to the particular weight part and add this 8 to the particular profit part. After adding, here it looks like. Again we have to compare this particular weight with the maximum capacity. Here we can observe that the 17 exceeds the maximum capacity. That means the path we chosen is wrong. That means what we have to do, we have to backtrack the process. While we have backtracking the process, we are having another chance of its previous node. That means not considering of that particular object. Since we consider the x3 object, then we can observe that the weight which we got exceeds the maximum capacity. That means we have to move on by not considering that particular object. After not considering that particular object, as we discussed before, the node which we are having the data is same as its parent node. That means 13 and 12 as we can observe here. Now we have to move on by considering the next object. As we can observe that we have considered or not considered. That means we have touched all the objects. That means no other object to consider. That means we have to end this process to this particular node. That means again we have to compare whether we have reached to the actual maximum capacity or not. The actual maximum capacity is 15 kgs, but the maximum capacity which we got here is 13 kgs. Though 13 is less than 12, but it is not equal to the maximum capacity which we have given. That means again the path which we chosen is a wrong path. That means we have to backtrack to its parent node. So in order to backtrack, the parent node is having two child nodes. That means considering of the x3 and not considering of that x3. That means the two paths have been completed. That means we have to backtrack to this particular parent node. Again we can observe in its parent node the both child nodes have filled. That means considering of the x2 object and not considering of the x2 object both have done. That means again we have to backtrack to its parent node. That means considering of the x1 object. While considering of the x1 object, we didn't get any positive results. That means now we have to move on to the further by not considering that x1 object. So while not considering the x1 object, as we discussed before, that means the data which we have in this particular node will be same as the data in the parent node. That means 5 and 10 will be same respectively. Now we have to move on to the further step by considering the x2 object. The x2 object is having the weight of 3 and profit of 6. That means we have to add this particular 3 to the weight part 5 and particular profit to the profit part 6. After adding, here it looks like. And now again we have to compare the weight which we got with the maximum capacity. The weight which we got is 8 and the maximum capacity is 15 kgs. 8 is less than 15 kgs. That means we can move on to the further by considering the x3 object. x3 object is bearing of weight 4 kgs and profit of 8. So we have to add this particular weight to the weight part and particular profit to the profit part. After adding, here it looks like. The weight which we got is less than the maximum capacity. That means we can move to the further step. But we can observe that we have touched all the nodes. That means we have visited all the objects. That means the weight which we got is not sufficient to the maximum capacity because 12 is less than 15, but 12 is not equals to 15. So in that case this path is wrong. Now again we have to backtrack to its parent node. The parent node is still having the chance of not considering that particular object, that is x3 object. So by not considering that x3 object, as we discussed before, that means the parent node, the data which is in the parent node is same as the data in its child node. That means 8 and 16 respectively. Again we can observe that the 8 which is less than maximum capacity 15. That means we can move on to the further. So but in order to move to the further, we are not having any other objects. That means the 8 is less than 15, but we have not reached to the maximum capacity. That means still we are having a space in our bag. That means the path which again we chosen is wrong path. Again we have to backtrack to its parent node. The parent node is having two child nodes, that is considering of x3 object and not considering of the x3 object. Both have done. That means we have to backtrack to its parent node. So x2 object is considered, but the x2 object not considered path is not done. That means we have to done that particular process. That means we have to not consider that particular x2 object. So as we discussed before, while not considering that particular object, the data in which we are having the parent node is same as the data in which we are having the child node. Now let us move on to the further by considering the x3 object. While considering the x3 object is having the weight of 4 kgs and profit of 8. So after adding this weight to its particular weight part and profit to its particular profit part, here it looks like. Now we have to compare this weight with the particular maximum capacity. Here 9 is less than 15. That means here there is a chance of moving to the further step. But we can observe that we have visited all the objects. That means we have touched all the objects. There is no other object. Still we are having the chance we have for moving further, but we are not having the sufficient objects. That means the path again we chosen is a wrong path. That means we have to backtrack to its parent node. So while backtracking to its parent node, the parent node is still having the chance of another child node. That is not considering of x3 object. While not considering of the x3 object, we can have that the same data in as its previous node. That means 5 and 10 respectively. But in order to move to the further, we are not having any other objects. That means still the 5 is less than 15. That means we are having 10 kgs of space in our bag, but no sufficient objects in order to fill that space in our bag. That means we can consider that the path which we have chosen is a wrong path. That means we have to backtrack to its parent node. The parent node, we can observe that both child nodes have been done. That means considering of the x3 object and not considering of the x3 object. That means it is not having enough space to store extra child node. That means again we have to backtrack to its parent node. So after backtracking to its parent node is also completion of two child nodes. That means considering of that x2 object and not considering of the x2 object, both have been done. That means again we have to backtrack to its parent node. Again we can observe that both considering of the x1 object and not considering of the x1 object have been done. Again we have to backtrack to its parent node. That means to the root node now. Now we have to do the process by not considering the x0 object. So as we discussed before, the child node, while we are not considering that particular object, the data which is in its parent node it should be in its child node. That means 0 and 0 respectively. Now we can move on to the further by considering the next object, that is x1 object. The x1 object is having the weight of 8 kgs and profit of 12. So we have to add this 8 to its particular weight part and 12 to its particular profit part. After adding, here it looks like. So now moving on to the further, we have to compare this 8 with the maximum capacity. So 8 is less than 15. That means we can move on to the further by considering the x2 object. The x2 object is having the weight of 3 kgs and profit of 6. We have to add this weight to the particular weight part and profit to the particular profit part. After adding, here it looks like. Now again moving on to the further, we have to compare this got weight and maximum capacity weight. The maximum capacity weight is 15 kgs. The weight which we got is 11 kgs. That means still we are having the space to store in the bag. That means we have to move on to the further by considering the x3 object. So the x3 object is bearing of weight 4 kgs and profit of 8. After adding those weight to its particular weight part and profit to its particular profit part, here it look like. Now in order to move on to the further, we have to compare this weight to the particular maximum capacity. The weight which we got is 15 and the maximum capacity is 15. So 15 is equals to the 15. That means the bag is full. Now in order to move on to the further, we can observe that there is no other objects. That means 15 is equals to 15. That means the bag is full. That means the path which we consider now is a correct path. That means we found one solution. We have got the solution by considering the x1 object, x2 object and x3 object by not considering the x0 object. There we can observe that in the profit part we are having the total profit which we gain. That means the total profit which we gain is 26. Since the process not yet completed, we can search for the another solutions which we can gain the profit which is greater than 26. So now again we have to backtrack to its parent node and we have to search for the another solution. So while backtracking to its parent node, the parent node is still having the capacity of storing another child node, that is not considering of the x3 object. While not considering of the x3 object, we can observe that the data which is in the parent node should be in the child node. That means 11 and 26. But in order to move to the further, we are not having the another objects. That means still the 11 is less than 15. We are having the capacity to store 3 kgs in our bag. But we are not having the sufficient objects. That means the path which we chosen is a wrong path. Again we have to backtrack to its parent node. We can observe that the parent node can store only 2 child nodes, but it is not having the capacity to store another child node. That means we have to backtrack to its parent node. So after backtracking to its parent node, this parent node is having the capacity to store another child node. That means not considering of the x2 object. The parent node is having the capacity to store another child node, that is by not considering the x2 object. So as we discussed before, the data while we are not considering that particular object should be same as the data which we are having in its parent node. That means 8 and 12 respectively. Now we will continue this process by considering the x3 object. x3 object is having the weight of 4 kgs and profit of 8 kgs. But we can observe that while adding this weight to the particular weight part and profit to the profit part, the weight which we got is 12 and profit is 20. But in order to move to the further process, we are not having any other object. Still the weight, that is 12 less than 15, that means we are having the capacity to store 3 kgs, but we are not having sufficient nodes in order to reach our maximum capacity. That means again we can say that the path which we have chosen is a wrong path. Again we have to backtrack to its parent node. While not considering the x3 object, we can observe that the data in its child node should be as the data in its parent node. That means here we can observe that the 8 is less than the maximum capacity of 15 kgs. But in order to move to the further, we are not having the sufficient objects in order to reach the maximum capacity. That means still the 8 is less than 15, but we are having the 7 kgs of space in our bag in order to fill our bag. That means again we can say that the path which we have chosen is a wrong path. Again we have to backtrack to its parent node, where we can observe that the parent node is not having the sufficient space to store another extra child node. That means again we have to backtrack to its parent node. Still this parent node is also not having the extra space. We have to move on to its parent node. That means we have to backtrack to its parent node. So while continuing this process, here it looks like. That means here we can observe that while considering or not considering any other objects, we can observe that no other solution we got. That means no other weights is not reached to the maximum capacity of 15 kgs. So after completion of the total process, we can observe that we got only one solution. That is by not considering the x0 object and by considering x1, x2 and x3 objects. That means we can say that we can got the total profit of 26. That means we can conclude that in our bag we can fit of maximum of 15 kgs with of maximum profit 26. So this is a knapsack problem using backtracking process. So if you need program for this particular problem, let me know through comments. So thanks for watching. If you need any extra concepts also, let me know through comments. Please like, share and subscribe for more videos. Thank you.